Chapter 3 Review. Graph the following and their inverses. Number 1, f of x equals log base 3 of x plus 2. So remember I talked about how to make the graph for the logarithm functions. Most of us do not like to work with the logarithm functions, so the best bet we have for it is to convert it into the exponential form, finding the inverse from the very beginning. So how do I find the inverse? I like to graph it. I like to find it using the algebraic method. I mentioned the table method. You can do that method as well. But for me to demonstrate it here, I'm going to use the algebraic method. Y equals log base 3 of x plus 2. So the first step is switch your x to the y to the x, as you put the input to the output, output to the input. Then solve for y. So I listed the step to your left. You can follow along. When y is all by itself, y equals 3 raised to the x minus 2, then we finally arrive at the inverse functions. So the inverse functions, remember I said the f, like raised to the -1 power, the -1 is not really a power, it's a symbol designation of the inverse functions. So the inverse functions of log base 3 of x plus 2 is 3 raised to the x power minus 2. So you can put down the inverse functions 3 raised to the x minus 2 power. So remember, I like to work with the exponential function, so I'm going to make the table from there. And I know 3 raised to the x minus 2 power, x minus 2. So our h is going to be 2, h is positive 2. That means everything is being moved right 2 units. So what are the x values I'm going to select? So from here, I'm going to select 0, 1, 2, 3, 4. And then the corresponding y value is 1/9, 1/3, 1, 3, 9. Once I have this table, all I have to do is switch it from the input to the output, output to the input. So basically, I just put 2 rows. And then I'm going to plot these points on the graph. So as you can see, for the exponential functions, I put it in the color red. So that's our exponential functions in color red. For the logarithm functions, I'm using the color blue. So make sure you follow along and then put these points on your graph. Your graph should look more accurate than mine. Question number 2. f of x equals log base 2 of x plus 4. So just like I did the previous examples, I'm going to use algebraic method to find the inverse functions. So first step, y equals log base 2 of x plus 4. Don't forget to rewrite the functions x to y, y to the x. So you are switching the input to the output. Then you solve for y. Solve for y. At this step, remember I said if the logarithm function is not working for you, then think about exponentials by rewriting it into the exponential form. The definition, 2 raised to the x power equals the argument, which is y plus 4. Subtract 4 to both sides to find the inverse functions. F of inverse equals 2 to the x power minus 4. From there, we do the graphing. And again, I use the exponential form to come up with the table. So this time, I'm selecting x equal to -2, -1, 0, 1, 2. Calculate the corresponding y values. And then I switch the table to get to the logarithm form. Then I plot. So the red one is representing my exponential function, 2 raised to the x minus 4 power. For the blue one, it's representing my logarithm form, log base 2 of x plus 4. So don't forget, for exponential functions, we have the horizontal asymptote. For the logarithm functions, we have the vertical asymptote. Question number 3. Log base 2 of x plus 1, then minus 2. So following the previous examples, I rewrite into y equals log base 2 of x plus 1, then minus 2. Switch the symbols from x to y, y to x. So this step you have to remember. You have to switch your symbol from x to y, y to x. Then you solve for y. So following the step, you can see I'm rewriting into exponential form and then subtract 1. So our final, the inverse function is going to be 2 raised to the x power plus 2, then minus 1. With that, I know the function is going to move left 2 unit, down 1 unit for the exponential form. Left 2, down 1 for the exponential form. From there, I plug it in the x values, so which is -4, -3, -2, -1, 0. So this is going to represent my exponential functions. In red. For the logarithm form, I'm representing it in color blue, which is this one. Log base 2 of x plus 1 minus 2. Question number 4. Now you are given the exponential functions. F of x equals 3 raised to the x minus 1 powers. To find the inverse, I'll do the same thing. Y equals 3 raised to the x minus 1 power. Then I switch the symbol from x to y, y to the x. So you have to do this step yourself. Switch the symbol from x to y, y to the x. Then again, solve for y. So solving for y, the next step, exponential form is not working for me. So then I think about logarithm forms. So I take the logarithm form on both sides with base 3 to rewrite the functions. And then the last step would be adding 1 to both sides. So the inverse function is going to be y equals log 3 of x plus 1. So y is all by itself. I know this is going to be my inverse functions, log base 3 of x plus 1. And since I'm given the exponential functions as the original functions, so I'll start with the table. And I know x minus 1 means that I'm moving right 1 unit, x minus 1. So x subtracting a positive number, moving to the right 1 unit. So my x value is going to be -1, 0, 1, 2, 3. Calculate the corresponding y. So I have 1, 9, 1/3, 1, 3, and 9. Then again, take the x values, make it as the output of the inverse functions. Take the y values, make it as the input for the inverse functions. And then plot it on your graph. So red is representing my exponential functions. Blue is representing my logarithm functions. Question number 5. F of x equals 2 to the x power minus 3. So first step, finding the inverse. Don't forget to re-switch your x to the y, y to the x. Solve for the y. So the inverse function is going to be log base 2 of x plus 3. So you have to put a parenthesis, otherwise the order of operation is not true. So make sure you put a parenthesis, x plus 3. So for the exponential functions, I'm using the table -2, -1, 0, 1, 2. Again, I switch the row from the input to the output, and then take the output values, make it as the input for the inverse function, log base 2 of x plus 3. Plot this on your graph. Check your answers. Question number 6. F of x equals 4. So now this time the base is 4. 4 raised to the x plus 1 minus 3. But following the same procedure as we did before, make sure you switch your symbol from input to the output to find the inverse. Switch your symbol from x to y, y to the x, then you solve for y. So the procedure we've been taking to find the inverse has always been the same. switch your symbol from x to y, then solve for y. So follow the step to check your answers. I have the inverse function as y equals log base 4 of x plus 3 minus 1. So find the values for the pick some values for your input x to the exponential functions. So this time I chose -3, -2, -1, 0, 1. Calculate the corresponding y values. I have -2 and 15/16. And then when x equal to -2, I have y equal to -11/4, and so on. Once you have this table, switch the values from input to output, output to input, and plot the corresponding points on your graph. Again, red represent the exponential functions, blue represent logarithm form. So questions from 7 through 16 is asking you to calculate the corresponding exponential functions and logarithm functions, simplify it, use your mental calculations. So whenever it comes to power, exponential form, logarithm form, always think about power. Think about your powers. And the clue should come with the exponent from the outer ones, that at the denominators. You want to get rid of the denominators. Not many of us like to work with denominators, so try to get rid of the denominators. Number 7, I can rewrite 25 into 5 raised to the second power. So again, the clue comes from these two, the denominators. Number 8, 27 can be rewritten as 3 raised to the third power. 8 can be represented as 2 raised to the third power. And again, the clue comes from the 3, the denominators. So number 9 is kind of lengthy. I know. There's the -4/3 times 3 over 5. So the clue again comes from 3 and 5. So I would like to make 32 into 2 raised to the 5th power. So the final answer for number 9 is going to be 1/16. Number 10, natural log. Natural log, ln represent natural log. The argument can be rewritten as e raised to the 1/3 power. E raised to the 1/3 power. So the final answer is going to be 1/3. Number 11, so as I mentioned in the class, this is the inverse. So it's almost like you can treat the log base 4 and the exponent base 4. Log base 4 and exponent base 4, they cancel each other. So you're simply left with the argument of your 3 raised to the second power, which is 9. Number 12. So using the power property on top of the product properties, 4 times. So remember, you have to bring the 2 back. So 3 is being raised to second power. Only the 3 is being raised to second power. So 4 times 3 raised to the second power, which is 9. 4 times 9 is 36. So this can be reduced down to natural log 36. Number 13. 3 raised to what power equals 81? Mental calculation. 3 raised to what power equals 81? 3 raised to the 4th power. Number 14. 1,000 raised to what power? Of 10. So 10 raised to the 3rd power is 1,000. When you don't see the base, 10 is assumed. So you have to remind yourself, if you don't see the base, 10 is the base. Number 15. 4 raised to what power equals 1/64? So I know 64 equals 4 raised to the 3rd power. But whenever it's at the denominator, I have to put the negative sign. -3 is the answer for number 15. Number 16. So again, the argument is looking for. So 4th root of 3. 4th root of 3 means that I'm looking for the 4th root. So the rational exponent form would be 3 raised to the 1/4 power. 3 raised to the 1/4 power. So the final answer for number 16 is 1/4. Question number 17 through 21 is asking you to solve for the x. So this comes down to a number equals a number. Can you make them into the same base? If so, make sure when they are the same base, then they have to have the same exponent. If you cannot make them into the same base, what do? Then think about exponentials from logarithms or logarithms to exponentials. So number 17, I can make them into the same base, so my x value is going to be positive 2. Number 18, again, I can make them into the same base, so my x equals 6. Number 19, I can make them into the same base, x equal to 3/2. Number 20, so this is rewriting from logarithm form into exponential form. 3 raised to the second power equals the argument, which is 2x minus 3. So that's the basic definition of logarithm form. 3 raised to the second power equals 2x minus 3. So my x equals 6. Number 21, can I make them into the same base? So to the right, 16, I can write it as 4 raised to the second power. And then the 2 can be brought to the front using the power property. So 2 and 2 can be reduced as I divide both sides by positive 2. So the only way for these two numbers equal to each other is the argument is the same. So x would have to equal to 4. Second part. Okay to use calculator. Solve when necessary, round your answers to 3 decimal places. Number 1, so the logarithm functions log x plus log x minus 21 equals to 2. For this one, I'm using the product property. So I'm multiplying the arguments together, x with x minus 21. So log x times x minus 1 equals to 2. Rewrite into the exponential form. If there's no base, the base is going to be 10. So 10 raised to the second power equals x times x minus 21. Distribute and then solve for the x. This is just a basic quadratic equation. X squared minus 21x minus 100 equals 0. So using the factor fish method, x minus 25 times x plus 4 is the given quadratic equations. So my x can be 25 or negative 4. But as you plug it in negative 4, it'll make the input. So if you plug it in negative 4, it'll make the input a negative number, which is not okay. So I have to exclude it. So the only answer would be x equal to 25. Number 2, 2 log base 2 of x plus 3 minus 2 log base 2 of 2 equals 3. So this one I'm just going to go ahead and make log base 2 of 2 as 1. Log base 2 of 2 as 1. So I'm going to add 1 to both sides to simplify the equation down to 2 times log base 2 of x plus 3 equals 4. Divide both sides by 2. I have log base 2 of x plus 3 equals to 2. Rewrite into the exponential form. 2 raised to the second power equals x plus 3. So my x equals positive 1. Number 3, I can rewrite them into the same base. A number equals a number. Whenever I can make them into the same base, I'll just rewrite them into the same base. So my x equals 1/2. Number 4, natural number. E raised to the x power equals 10. So I don't think anyone can make this 10 into the base of e. So I just have to take the natural log on both sides. Natural log. ln stands for natural log. So my x equals 2.303. Number 5. So when I look at this question, I know 16. I notice that 16 is 4 raised to the second power. 4 raised to the second power. So I just go ahead and rewrite that and use the power property to find my x equal to 4. So the only way for these two numbers equal to each other is they have the same argument. So x equal to 4. Number 6. 3 raised to the x power equals 100. Again, no one will be able to make 100 into base 3. So I'll just have to take the log on both sides. Log 10 on both sides. So log 100 is going to be 2. Divide both sides by log 3. So my x equals 4.192. Make sure you are able to find this on your calculator. Practice it and ask questions you may have. You have to know how to find these numbers on your calculator. Number 7. So again, log base 3 of x minus 2 plus log base 3 of x minus 3. So this is the product properties. I multiply the argument to the right-hand side, 2 log base 3 of x, rewrite that into x squared. So x minus 2 times x minus 3. Expand that, x squared minus 5x plus 6 equals x squared. Subtract both sides by x squared. I have x equals 6/5. But as you plug the numbers back into the equation, you can see 6/5 equals 1.2. So 1.2 minus 2 is going to be a negative number. 1.2 minus 3 is going to be a negative number. So there's no solution for this particular number 7 questions. Number 8, natural log. Natural log, I'll just rewrite into the exponential form. So e raised to the third power equals the argument 4x plus 5. Subtract both sides by 5 and then divide it by 4 to find my x equals 3.771. Number 9. So I'll start with dividing both sides by 5. 5 times 10 to the x power. So I divide by 5 first. 10 raised to the x power equals 45. Take the logarithm form on both sides. So my x equals log 45, which is 1.653. So make sure you practice finding these numbers on your calculator. You will need this on your chapter test. Calculate your interest. Number 10. If you invest your $20,000 at 6% compound quarterly. So again, the keyword quarterly. So quarter means there are 4. How long will it take you to have 25,000? For A, letter A, 25,000. So how do I do this problem? 25,000 equals 20,000. So the final value, 25,000, is the goal you want to reach. 20,000 is what you start with. E times 1 plus 0.06, that's the interest rate you are given, divided by 4 because you are compounding quarterly. So make sure you divide your interest by 4. Then your exponent would have to be 4 times t. So if you divide by 4, then your exponent would have to multiply by 4. 4 times t. Divide both sides by 20,000. I have 25 over 20 equals, so 0.06 divided by 4, I have 0.015. So 1 plus 0.015 is 1.015 raised to the 4t power. 25 divided by 20, make that into the decimal form, that's 1.25. So take the logarithm form on both sides. Log 1.25 equals log 1.015 raised to the 4t power. So 4t times, using the power property, 4t times log 1.015 equals log 1.25. Divide both sides by 4 times log 1.015 to find my t equals 3.75 years. So the subsequent letter B and C and D are using the same method. So check your answers for letter B through D. B, I have 6.81 years. C, I have 15.39 years. D, I have 27.62 years. Number 11. Which plan would yield you more interest? Would give you better return on your investment. So plug in the numbers according to the interest rate given. First one is compound annually. So that's simple interest. 30 years, you will get, after 30 years, you will get 17,230.47. Plan B, it's being compounded daily, so you have to divide that by 365. And then correspondingly, your exponent would have to be multiplied by 365. And then the calculation turns out to be 16,835.28 cents. So plan A would earn you more by 395.19 cents. Make sure you try this on your calculators. You will need this to take on the chapter test. Question number 12. You're going to invest $2,000 in the bank and the annual interest rate is 8%. How much money will you have in 10 years if it compounds? So letter A, yearly. So this is going to be a simple interest rate, 2,000 times 1 plus 0.08 raised to the, so 10 years, raise that to 10 years. Calculate that, put in the calculators, you'll find A of 10 equals 4,317.85. Letter B, quarterly. So quarter means you have to divide it by 4. A of 10 equals 2,000 times 1 plus 0.08 divided by 4 raised to, so this time you have to multiply your year, your time by 4. And that turns out to be 4,416.08. Letter C, continuously. Whenever it is continuously, you have to change that into E. Your interest rate becomes E. Your base becomes E. The base becomes E. So P of 10 equals 2,000 times E raised to the 0.08 times 10. So the final answer is going to be 4,451.81. Letter D. If you want to double your money being compounded continuously, how long do you need to leave your money in the bank? So double means starting with 2,000, you end up with 4,000. That's doubling. So my final value, I want it to be 4,000. 4,000 equals 2,000 times E raised to the 0.08 times T. So first divide both sides by 2,000.